Let's discuss what's responsible for the day and night and the seasons at the surface of the Earth. To do that, I'm going to go to this simulation here. Actually, the graphics are not exactly from the simulation, but the simulation will help illustrate this best. Focus on how the Earth looks in that simulation and how it is going to spin and rotate about the sun. The yellow object is supposed to represent the sun. Okay, here's the simulation. Now it's three-dimensional, so I can rotate it around. In this position here, let's focus on it by zooming. And you notice how the Earth is spinning about its axis, this line between both poles. And notice the way that line is actually tilted towards the right side. Now, this part of the Earth is lit, while this part is dark. Why is it lit? Because, as you can see it when we zoom out, because it is facing the sun. It's getting the light from the sun. While this side is the opposite side of the sun, and that's why we don't see it lit. Let's focus on that for a little bit. Now I'm going to move to other positions, for example here. Now here we are not looking at the side of the Earth that's facing the sun. That's why we see it dark. We are looking at the dark side of the Earth, or the side that's experiencing nighttime right now. Okay, if we go here, now this is the side facing the sun. Now note how when we are seeing the sun rotating, the Earth rotating about the sun, this axis is always tilted towards the right. It's not always tilted towards the sun. Now it is. But it is tilted towards the right. For example, look at it here. It's tilted, still tilted towards the right. Here, it's again tilted towards the right. And here, it is again tilted towards the right. And let's look. Now we are seeing the face of the Earth that's facing the sun. We are seeing parts of the Earth that are experiencing daytime. Like these parts here, they are experiencing sunrise, while these parts here are experiencing sunset. Okay, so two things are established, I hope. The axis of the Earth is always pointing in the same direction. And the Earth rotates or spins about that axis. And that spin is going to happen once every 24 hours, resulting in the daytime and nighttime. Okay, let's go back here and let's zoom back. Now, when we zoom, notice how these parts that are experiencing sunset go into night, and the other parts are going to experience sunrise from the other side. We don't see it exactly. Now, if we focus on this line here, which represents the equator, the amount of daytime, if we measure it here, is equal to the amount of nighttime. But if we go to somewhere here, if we draw the parallel to that green line, which I cannot draw here, the daytime is shorter than nighttime. Here, that's the opposite. Daytime is this much, while nighttime is this much. Short day, long nights, that's winter. Long days, short nights, that's summer. Moreover, One thing that you can focus on is the fact that the North Pole here is never experiencing daytime. It's 24 hours of night. So when you see its image, it is in the dark. It is at night. 24 hours of night. That means in the North Pole, in the Northern Hemisphere, we have winter. While the South Pole is experiencing daytime the whole time. So it is summer for the Southern Hemisphere. Notice how the seasons are opposite. Winter, summer. In opposite hemispheres. So now if we go here, notice here there is no differences in lighting between the Northern Hemisphere and the Southern Hemisphere. This is what happens during the autumn and the spring. That's when the daytime is equal to the nighttime. That's what we see here. Now, if we go here, look how the seasons are reversed. North Pole is experiencing daytime all the time, so it is summer in the Northern Hemisphere, while the South Pole is experiencing nighttime all the time, so it is winter in the Southern Hemisphere. I hope that one helps. Now, when we look at this image, so then it is obvious this is daytime. This is, we are seeing the side facing daytime. We are seeing the dark here, the side of the earth or the face of the earth that's experiencing nighttime. Here I have longer day than here, so I have summer here and winter here. The North Pole here is experiencing darkness 24 hours, so I have winter here. South Pole is experiencing 24 hours of daytime, so it is summer here. Here, same length of daytime and nighttime, so it is fall and spring, similarly here. The key point to remember here, as the Earth rotates about the Sun, its axis is always tilted in the same direction. Because of that, part of the Earth are going to receive. Because of that, parts of the Earth are going to receive. Because of that, parts of the Earth are going to receive more light at some times than some others. For example, the Southern Hemisphere is receiving more light here and experiencing summer, is receiving the same amount of light here as the Northern Hemisphere, and it is experiencing then fall, and it is experiencing less light than the Northern Hemisphere, and it is experiencing winter. It is the fact that the axis is tilted is what's determining the seasons. The rotation about the axis of the Earth, or the spin about the axis of the Earth, is what's responsible for the daytime and nighttime. And day is short or long, again, because of the tilt of that axis. So again, facing the sun is bright, away from the sun is dark. Okay, so this is summarizing exactly what we talked about. Okay, notice here which parts are experiencing sunset. Since the Earth is rotating like this, it's going to be C and J. Where do we have the longest daytime? So it's going to be at E. Draw the parallel to the green line here, and you see quite a long day and a short night. which position on the Earth is receiving the most sunlight. Of course, it is E again because it has a longer day. Okay, now if the Earth were not tilted, the part of the Earth that's receiving the most sunlight is going to be none. They all receive 24 hours of daytime and 24 hours of nighttime. So it's going to be the same. Okay, here the southern hemisphere is receiving more light than the northern hemisphere. So it is summer for the southern hemisphere. Now, if it were not tilted, it would be the same. Now here we are focusing on something else. Which part of the Earth is getting the most direct sunlight? In this case, it is the one that is hit by ray 4 from the sunlight. This is where the sunlight is direct. While here it is less direct. The further away we get from 4, which is the southern tropic here, the less direct sunlight we get. The more direct sunlight, the more effective it is going to be at warming up the Earth. If the Earth were not tilted, the most direct sunlight is going to be at the equator. You know, we have the image of this lady here to essentially help illustrate for us that direct sunlight, like the hair blower, is going to be most effective when it hits head on, like 4 here or 4 here. Okay, and here the northern hemisphere is experiencing summer, the southern hemisphere is winter, and the opposite seasons here.